Let me first point out a wrong information that I provided to you in the last class. I said that when in Fortran 77 the executable command can be written between the columns 7 to 82. It is wrong. Actually it should be 7 to 72. Sorry for giving wrong information. Let's come into the example, the homework that I gave you in the last class. The aim was to find out the sum a plus b, a plus minus b, a by b, and a to the power b. These are the 5 arithmetic operations were asked to perform for two given a and b. So we start writing 7 column onwards. First thing is read a comma b. So this reads the two inputs a and b. Then the to write the sum, we write the expression sum as a plus b, difference a minus b, product a star b, and division a by b, exponentiation a double star b. Now all the things have been calculated. Now it is time to write this. We may write this as like this. A b sum diff etc. Then then we finally write stop and end. Stop, as I have stated in the last class, stop is the logical stop. If we write stop over here, the program will execute all these things but will not write because it has been asked to stop prior to this line. If we execute this thing, then in the output we will get 1, 2, 3, 4, 5, 6, 7 quantities written one after another. As for example 1, 2, 3, minus 1. As you have written the program, you know what is what, but somebody else who hasn't written the program, to him it will be just 7 numbers. So we must represent the result in a way which would be understandable to everybody. I am first going to this part. So the calculation has been done and this must be represented in a proper way, so a person who hasn't written the program, to him too the program will be explanatory. So we write it as inputs within colon. So what it writes in the output, instead of writing 1 and 2, the example that I have considered, it will write inputs. The thing that has been written within the inverted comma will be copied exactly in toto, and then this sequence has been broken by this comma, and then it will write the value of variable a and b. So whenever this line comes, everybody will come to know that they are the inputs. If one writes, wants to write it as inputs A is equal to 1 and B is equal to 2. For this statement has to be changed a bit. A gap, this is the blank space, this is blank space, and then A is equal to again a blank space, inverted commas ends, the inverted comma that started over here ends here, so this is an end of a string. Then we write the variable A, this is comma, then A, so it writes this part will be written in toto, so it writes inputs colon gap A is equal to a gap, then it writes the value of A. Then we start with the inverted comma, put a gap, then B is equal to, with a gap comma B. So what it writes, after finishing A, it will give a blank space, then B is equal to a blank space, then the value of B. There will be a gap, and then it writes the value of B. So in that case, the output will be exploited. This is the string we have used, the thing that is written between two consecutive colon or inverted comma will be copied exactly, and each string will be separated by a comma. This is a string which is separated by a comma, so this indicates that the end of this string, then this is the variable name, this is another another string, and this. Now to write the outputs can be written as then we write A plus B is equal to blank comma sum. It writes simply A plus B with a blank, this B with a diagonal line stands for blank or empty space, so this will write B blank comma the value of A plus B, so it will write A plus B is equal to space 3. In that way we can write the other outputs either in separate lines or in a same line separated by comma. It may so happen that if we want to write all these five things, they may not be accommodated within 72 columns. So in general, whenever in writing in English literature, say towards the end of the notebook we write then we put a hyphen, and in the next line we lay accommodation. That means just in the line after next line the word this part will be taken and added at the end of this. In Fortran, what one do is the other thing. If one line, say it is 7 to 72 column is there, and our writing is accommodation, we take the example. So at the 72 column we have A, and in literature we put the hyphen after this, but in Fortran we place any character on the 6th column and we write TION. That means TION will be added after A. So the 6th column is called the continuation card. I have chosen this problem deliberately to introduce this continuation column or continuation card. So if you write anything at the sixth column in Fortran 77, it will assume that the previous line is not complete, so it will take everything and will add it at the end of the previous line. The previous line may not end at 72 column, it may even end at 22 column, even if what is written in this line will be added after the 20th column of the previous line. If you want to have more than such continuation, say we have a line 1, then this is 6th column, 7th column. Then in the 6th column I have written this is line 2, line 3. Then what it will do? It will assume that this line 1 is not complete, so it will add line 2 over here. Here we will have the line 2, and it indicates that line 2 is not complete, so it will add line 3 over here. So for execution is concerned, this line is a combination of 3 lines. So this is the use of continuation card. And similarly, the 6th column is continuation column and 1st column is called a comment card. Comment card. Say for example, you want to write that this program has been done by Mr. X, and this has nothing to do with the Fortran programming. So whenever the compiler compiles this program, he will find that any line which has some non-zero or have some character in the first column, then it is a continuation card, and this has not to be converted into machine language. So this line will not be compiled, it will be just omitted during compilation. Now I come to the variable nature of variable, that is the real variable and the integer variables. And we'll do some simple exercise on it. In mathematics, a real quantity means a square is greater than 0. Greater than or equal to 0. This is the definition of real quantity in mathematics. In computers, in the language of computer, real means I am confining myself to Fortran only. In Fortran, real means having decimal part. A quantity having decimal part. In contrast to real, one speaks of integer, no decimal part. So if we consider constant, say 1 is a constant, if we write it 1, so there is no decimal part, so it is an integer. If we write it as 1.0, then it will be real, because even if the integer part is 0, but there is a decimal point, so it will be a real quantity. So if we write 1.39, then it is a real constant. It is real constant. The corresponding integer constant is 1, simply 1. Now these are the real. So if we do this thing, 1 divided by 3, So the result, this is the division of two integers. The result actually result is 0.3 recurring, but since this is the division of two integers, the result will be equal to 0, because it will just ignore the decimal part and the result is 0. This is called integer operation. Another thing is that if we write it is 1.3, then the result is 0.33. If we write it 1.3, then the result is also 0.333. And if we write it 1.3, then also the result is. This is called integer operation, because all the constants involve the integers, and it may also include variables. That way I will come later. This is called the real operations, because the quantities involved are real, and these are called the mixed mode operation. Mixed mode operation, because it involves a real with and an integer and a real. So there are three types of arithmetic operations. In terms of the variable character, they are either integer operation. If we perform an integer operation, the result will again be an integer, and for the mixed mode and real mode operation, the result will be a real. This must be kept in mind. This is very important. In many cases, this leads to wrong result, because one writes 1/10 and expects to get 0.1, but he gets 0. Now, how the Fortran programming will know that a variable, whether it is a real variable or integer variable? This is now the point that I am going to address now. In Fortran, any variable must start with an alphabet. So it may starts with A, and a variable name starts with A or B or C up to H, then I, J, K, L, M, N, then we have O to Z. This is the English alphabet. If you do not specify anything from outside, then it says that any variable name that starts with this letter are real variables, and these are also real variables, and anything that starts with this are integer variable. Say we consider a quantity called a variable is named as this, a integer. Say this is the variable name, this is a integer. The name starts with A, so in general it is a real variable. It is a real variable. Anything, say sometimes we need to write lambda, then one generally writes it. But in writing this, mind is, if the word, the variable starts with L, then it is an integer variable. But you may have lambda value 301 point something nanometer. Then what should we do? We put a R before this. If we write this as R lambda, that means it starts with R, so this R has been added to make it real, and this lambda means this quantity represents the lambda that has appeared in the mathematics, but it is in the real mode. Similarly, if you represent mu as the refractive index of a material, so for water it is something 1.3, then we must not write as mu but I write r mu, so that it will accept the value 1.33. Otherwise, what happens? Let me show something. I write a Fortran program, read mu, and I asked it to write mu. This is a simple Fortran program, and during execution in the read line I provide the value of m to be 1.33, mu to be 1.33, but it assumes the value you have from the keyboard 1.33, but whenever it comes it says that it is a integer variable, so it removes the integer decimal part and converts it into 1. So whenever you write mu, it will write 1, not even the decimal point. This is one problem. Another thing, if we write it to be a, and during execution I put the value of a to be 1, then since a is a real variable and I ask the program again to write a, it will write at least 1 point. Some compiler writes it at 1.00, but it will, in every compiler the common part is that it will write 1 point, because a is a real variable, so it will have a decimal part. It may decimal point and the decimal part may be 0. Some compilers writes these zeros, or some compiler does not write, but the decimal point is there. Another example will be found very helpful. We calculate within the program x is equal to 1.3 and ask the computer to write x. Then what it will write? During operation it will calculate this to be 1.33 0.33. Since the operation is in integer mode, so 0.33 will be converted to 0.0. So 0 will be assigned to x, and since x, the variable name starting with x is a real variable, it will add 0 to it. So the output will be either this or this. Again, let me clarify the point once again. 1.3, this is an operation in integer mode, so the actual value 0.33. Since it is an operation involving integers, it will remove the integer part and the result, the quotient will be 0, and 0 will be assigned to x. Since x is a real variable, immediately 0 will be converted to 0 point. So the point of caution is that you must be very careful about the starting alphabet of an integer, and you must be aware of the nature of the variable that you are using, whether it is an integer variable or a real variable. Otherwise you may land up with wrong result. Now the next thing that I want to discuss is the natural flow of the control statement. Let me come to the control statement. I am using logical if statement. Logical if statement. In reality, we generally ask some question, and some question, say for example, is A greater than B? If yes, then we do something. If no, we do something else, and then the conditional calculation ends. So in a calculation there is a part whose calculation depends on the question, on this question. If the answer is yes, then something is done. If the answer is no, something else is done. As for example, the representatives are set some targets. So let us consider a representative has been asked if he could give a turnover of 1 lakh per month, then he will get an incentive of 1% on the turnover, and if the turnover is less than 1 lakh, he gets nothing. Such a question arises. So if we consider the turnover, it is the turnover, the variable turnover. We generally read it from input, and then one asks whether it is greater than 1 lakh or not. Then if it is greater than 1 lakh, then incentive is calculated. If it is less than 1 lakh, no incentive is calculated. So how to implement this in Fortran? I am going to do this. So before this, I first like to say that there are 6 logical statements. These are equal to. This is written in Fortran as EQ dot, not equal to. This is not equal to. Greater than. This is dot GT, greater than equal to. GE is the greater than equal to. Less than, LT is less than, and less than equal to, LE is less than equal to. So these are combined by 2 alphabets, and there are dots before and after the statement. Some compiler accepts this, but there are no provision for this. There are some compiler in which dot EQ dot is equivalent of writing equal to sign from keyboard, and similarly for less than and greater than sign, but not equal to sign, they cannot be implemented from keyboards. So I consider a very trivial example from mathematics, that is the definition of mod function. This is equal to plus x if x is greater than or equal to 0, and this is equal to minus x if x is less than 0. I want to calculate the absolute value of x. So the program starts with 7th column, read star comma star x. Then I first ask this question. This is if x is greater than or equal to. Since I have written x, it is a real variable, so I can check a real variable with a real one. So if x greater than equal to, then we write, then this is absolute value is equal to x, else now first thing, say for example x is given 5.9. So from our keyboard we have inputted 5.9. Then it comes to this question, and it finds that the answer to the question is yes. Then the program proceeds to the next line, that is to this line, and it calculates this, and this calculation continues up to the line prior to the else, prior to the line up of else statement. So if there were 5 lines, all the 5 lines will be executed. If there are 5,000 lines between if and else, then all the 5,000 lines will be executed. And then program comes to the line just after the end if, where we generally write x and abx and then stop end. If what happens if one uses x value to be minus 2.1, then the question, the answer to this question is no. Then the program directly jumps to this line and it skips all this line between if and including else. So this is a control, and it comes to this part and calculates ABS of x as 2.1 and then writes this. This is the general control statement or the operation of logical if. I am writing the statement if within bracket the question that is to be asked question. Then there are few lines. These lines will be executed when the condition is yes, the condition asked is satisfied. Here, as for example, x greater than 0, in the first example with x is equal to 5.9, the condition was satisfied, so all this line will be executed, and then it will, from there it will jump to this line, just the line after the end if. And there are few other lines, these will be executed when the condition is not satisfied, when the is not satisfied. In that case, the program control will be like this. The program just after this line comes here to the, if the condition is not satisfied, then the program jumps from after this line, jumps to the line just after else, and it will skip this line. And if the condition is satisfied, then these lines will be skipped. This is a control on Fortran programming. If no control is done, then in general the Fortran programming proceeds from line 1, then to line 2, then line 3, line 4, etc. And so one line by line, and in a line the operation is executed from right, and the result that is obtained is assigned on the quantity that is put on the left hand side of the equal to sign. In the next class we shall consider another control statement, that is the let me go to the goto statement also. Another type of control statement is the goto statement. Sometimes it is found in Calcutta that some roads are blocked due to somewhere, so whenever one wants to go to Esplanade from Sealdah station, generally he takes Lelin Sharoni or SN Banerjee road. Say these roads are occupied due to some reason or other, then one instructs the traffic to go to the Park Circus and come to Esplanade down the Jawaharlal Nehru road. So these control are needed. Sometimes say you again ask a question, if A greater than B, then then one says to go somewhere, and then else and if. We may ask it to go to blank an integer number, and here we can also say go to blank some other integer number, These integer numbers are called the statement numbers. Earlier I have explained the term in Fortran. I have said this is the comment card, this is continuation card, and Fortran program in 77 could be written between 7 to 72. And go to statement, this statement number, say if one writes 11, this 11 must be written between these 2 to 7. It may be written between second and third, or between third and fourth, or between fourth or fifth, but not one on second and other one at fifth. No, this is not allowed. You may write in 2 consecutive columns, or if you use the statement number in 3 digit, then 3 consecutive numbers. The statement number that can be put is between this. It should be an integer, positive integer, and must be put between the columns 2 to 5 in consecutive columns. No gap should be there. Let me explain this with an example. Whenever it finds the statement go to 11, it will find where 11 is written between 2 and 5, which is called statement number field. This is called statement number field, because it has a width, so it is the field, not a card. It will find where 11 is written between 2 and 5 column. It will jump there. It has no relation with the line number. Let me do this thing, or consider an example. If read x, if x is greater than or equal to 0.0, then go to blank 13, else go to blank 5, and if. I write 5, then stop it. How does the program works? Say x is equal to 5.9. So the question is, yes, it comes to this, and it has been asked to go to 13. Sorry, this is 13. It will directly jump to 13. It will calculate ABS of x is equal to x and writes x and ABS, then stop it. If x is minus 2.9, then it comes there, and it has been asked to go to 5, and from 5 it calculates the absolute value, and it has been asked to go there. if this statement were not there, then what it would do? It would do first x is equal to minus 2.9 minus 2.9. So in this step, in the step 5, it will calculate absolute x is equal to 2.9. Then in this step, this line, if this line were not there, in the 13th statement number, it will again calculate it as 2.9, and it will write x as minus 2.9 and absolute value is 2.9. In this case, both the statements will be executed. But if we want to skip this statement when 2 is x is equal to 2.9, so this bypass is made by go to 10. So these are the two types of control statement. One is the logical if statement, another one is the go to statement. With the help of this, in the next class I shall write a program to find the roots of a quadratic equation with real coefficients.